Hi dear friends, welcome back to our channel Anvinay Kumar Basics of Physics. This is the right place to learn. Dear friends, in this video we are going to discuss about how the light rays can behave when they are incident on a curved surface. This is the topic belongs to the chapter Refraction of light at curved surfaces. Children, this is the chapter Refraction of light at curved surfaces, and the topic is we are going to discuss how do rays behave when they are incident on a curved surface. Clear? How the light ray is going to be behave when they are incident on a curved surface. Curved surface may be either it is concave or convex. Clear? So here already we know that refraction of light. What is refraction of light? When the light ray is moving from one medium to the another medium, the light ray is going to be bent because of change in velocities. Clear? That is what we call refraction of light. When the light is moving from one medium to the another medium, at the interface the light ray is going to be bent because of change in velocities. That is what we know refraction of light. Refraction of light belongs to two media. Clear? It is rarer or denser to rarer or rarer to denser, denser to rarer, anything. Clear? So here what is curved surface? Curved surface is nothing but, for example, this is the one curved surface. Clear? So on this side we have medium 1 and on this we have medium 2. Clear? The surface which can separate the curved surface is nothing but it is separating the two media, medium 1 and medium 2. And it is medium 1 is denser and medium 2 is rarer. If medium 1 is rarer and medium 2 is denser, the surface can separate the both medium. And now here already we know about the definitions of pole, center of curvature, focal length, focal point. Same definitions applicable to here also. Okay, in next coming video we discuss about the focal length, radius of curvature, remaining all those things. But in this case we have to first know about the center of curvature of a concave or convex surface. Clear? Already we know what we know. If you can draw so many normal lines, if you can draw, for example, this is the one circle. This is what? One circle. Here we are taken off part we are taken. So only now we are taking this one. Clear? From where we are taken? From a sphere. From the sphere we are taking this only. Clear? So now this point is nothing but center. Clear? We are taking a sphere. The center of the sphere is nothing but center of curvature of any spherical surface or curved surface. Look here. మనం ఒక సెంటర్ ఒక స్పియర్ తీసుకున్నప్పుడు ఆ స్పియర్ యొక్క సెంటర్ ఏమైతే ఉంటుందో దట్ సెంటర్ షుడ్ బి టేకెన్ యాజ్ ద సెంటర్ ఆఫ్ కర్వేచర్ ఆఫ్ ఏ కర్వ్డ్ సర్ఫేస్. క్లియర్? వెరీ సింపుల్. నౌ we are drawing so many normals onto that particular point. That is what you have to say center of curvature. So that is what principal axis. So here that is what we call center of curvature. Look here, the definition is on the board. The normal lines drawn from the spherical surface meet at one point on the principal axis is called center of curvature. So children, in this diagram, so here this is the air, nothing but rarer medium. What is rarer medium? And the light is coming from where to where? Rarer medium to the denser medium, and the light is parallel beam of light. So here we are not talking about the refracted rays in this diagram. Simply here the red color what you are finding in this diagram, they are represents the normal lines. From the curved surface we drawn so many normal lines. They will meet at this point. That point what we call center of curvature. So here definition is there. You have to note it, children. Clear? The normal lines what we are drawn from the spherical surface or curved surface, they will meet at one point. That should be what we call center of curvature. Clear, children? Now we are going to discuss how the light ray can behave when it is incident on the a curved surface. In that, the first rule, when the light ray is moving from rarer to denser medium, from where to where? Rarer to denser medium. If the light ray is passing through the center of curvature, then there is no deviation for refracted ray. Clear? So in this diagram you have to observe, this is the rarer medium and this is the denser medium, and this is the one curved surface, and the light is entered like this because the light is enters normally. Clear? So ఇక్కడ మనం ఏవైతే నార్మల్ లైన్ గీసినామో అదే నార్మల్ లైన్ వెంబడి లైట్ రే ఇలా వచ్చేస్తుంది. క్లియర్? దెన్ దెర్ ఈస్ నో deviation of its path. That is the first rule you have to remember. When the light ray is passing through the center of curvature, there is no deviation of its path. Why? Because it is incident normally. Clear? So this is the rule number 1 you have to remember. While you are watching this one, you have to prepare the notes. Okay, next we go for rule number 2. See the next diagram, children, and next rule. Look here. A ray passing through the pole after refraction, there is no deviation in its path. So see the diagram, children. So this is the curved surface, and the red color what we are showing, that is the light ray. So that is incident normally. That's why there is no deviation of refracted ray. So according to Snell's law, the ray which is touches the normally, thus for that there is no deviation of refracted ray, there is no deviation of its path. So already in next we discuss what it is here, already in previous diagram we discuss what it is, the ray which is passes the center of curvature, for that also there is no deviation. It means that what, according to Snell's law, what you have to say, the rays these two are incident normally onto the curved surface, then obviously there is no deviation for refracted rays. So in this case also ray is moving from rarer to denser medium. Okay, children, next rule you have to remember, very important one, that is what, when the light is moving from rarer medium to denser medium, the refracted ray is bent towards normal. When the light is moving from rarer to denser medium, the refracted ray is bent towards normal. So children, in our textbook the same thing is explained with the 2 diagrams. Look here, you have to don't confuse. In this case, this is what rarer medium and this is what denser medium, and this is the incident ray and this is the refracted ray. Clear? So in this diagram the light ray is moving from rarer medium to the denser medium, and the surface is nothing but what is like concave surface. It is a curved surface, but again that is the concave surface. So that's why here the ray is coming like this, and after refraction it is bends towards normal. The dotted lines what we are showing, this is the normal line. So the ray, when it is moving from rarer medium to the denser medium, it is bends towards normal. Clear? So you have to remember very simply, it is now this is the angle of incidence and this is the angle of refraction. So in this case what you have to say, angle of I is greater than angle of R. Clear? Angle of refraction is less than the angle of incidence when it is moving from rarer to denser. So ఇదే కాన్సెప్ట్ ని ఇంకో డయాగ్రామ్ ఇచ్చారు చూడండి. So now it is convex surface. What is convex surface? And this is the rarer medium and it is the denser medium. Clear? Again the light ray is passing from rarer to denser, and after refraction it is bends towards normal. Again same thing, angle of I is greater than angle of R. So this is the angle of I and this is the angle of R. Clear, children? So you have to remember very clearly. See the next rule, children. This is also important. When the light ray is moving from denser medium to rarer medium, the refracted ray is bends away from normal. Light is moving from where to where? Denser medium to the rarer medium. After refraction, the ray is bends away from normal. So for that, in our textbook 2 diagrams are given. Look here, this is what denser medium and this is what rarer medium. So the light is moving from denser medium to the rare medium. So children, this red color is the light ray and this is the surface and this is the principal axis. Ray is passing from denser medium to the rare medium, and now in this case what I have to say, the rays moves away from normal. That's why in this case what I have to say, this is angle of incidence and this is the angle of refraction. So children, the dotted line, what it is? Normal line. What it is? Normal. Clear? That's why in this case what you have to write, angle of R is greater than angle of I. When the light is moving from denser to the rarer medium, angle of refraction is more than the angle of incidence. Why? It is moving away from normal. So children, ఈ diagram రెండు డిఫరెంట్ అనిపిస్తాయి, కానీ సేమ్ ద లైట్ ఈస్ మూవింగ్ ఫ్రమ్ డెన్సర్ టు రేర్. కాకపోతే మీరు అర్థం చేసుకోవాల్సింది ఏంటంటే, నౌ దిస్ ఈజ్ ద కాన్వెక్స్ సర్ఫేస్ అండ్ దిస్ ఈజ్ ద కాన్కేవ్ సర్ఫేస్. సో అగైన్ ద లైట్ ఈస్ కమింగ్ ఫ్రమ్ డెన్సర్ టు ది రేర్ మీడియం. So light is coming from denser medium to the rare medium. After refraction, it is moves away from normal. This is what normal line. డయాగ్రామ్ చాలా జాగ్రత్త అబ్జర్వ్ చేయండి, కన్ఫ్యూజ్ కావద్దు. మనం కాన్వెక్స్ కాన్కేవ్ సర్ఫేస్ని ఈజీగా ఐడెంటిఫై చేయగలిగితే మనం డయాగ్రామ్స్ ఈజీగా డ్రా చేయగలుగుతాం. సో ఇక్కడ లైట్ ఎక్కడి నుంచి మూవ్ అవుతుంది, ఇట్ ఈస్ మూవింగ్ ఫ్రమ్ డెన్సర్ టు ది రేరర్. ఆఫ్టర్ రిఫ్రాక్షన్, వాట్ యు హావ్ టు సే అగైన్, దిస్ ఈజ్ R and this is I. So angle of R is greater than angle of I. So children, you have to remember these rules very clearly, and these are very useful in coming topics. So we will meet in the next video. Bye, take care.